Hi, this is my answer to why model. This is for the TOM Virtual Summer School. This will be based on a paper I wrote last year for the Journal of Management, which is aimed at PhD students, help them to answer exactly this question, why model, what are the benefits, and also talks about some other things related to models, like how to write a modeling paper and how to decide which may be a better or worse modeling idea. Regarding the benefits, in that paper I talk about 7 benefits that I group into things that help with theory development, things that help with theory testing, and some general benefit. So let's start with the first one. So the first one is to facilitate making complex predictions. So for example, in this paper I wrote with J.P. Eggers, we wanted to predict how different structures could make decisions. Doing this in your mind is very difficult, if not impossible, while a model can do that very directly. So that allowed us to make predictions that we couldn't have been able to do without the model. Second, to help study phenomena for which there's no yet ideal data. So for example, during the early 2000s, there was a lot of development made in the field of organizational design by looking at models of organizations. As you know, it's very difficult to measure things inside organizations, difficult to get access to them. It's difficult to measure the exact things that you need for your theory. But if you know some mechanisms and you can put them into a model, you can use the model to study that phenomena to some extent. Of course, you need to make good assumptions that are validated. Later, when there was good data because of internet and because of databases that became available, then people was able to study again org structure using data. But when you don't have data, models can help. Models also increase theoretical precision. So for example, when people talked about value until like 20 years ago or a little bit more, before this paper by Brandenberger and Stewart, people hand-waved a lot. The same with the idea of adaptation. But this paper, Brandenberger and Stewart, and the paper by Leventhal, 97, define those two terms. So when you are able to build a model on something, you need to be able to define that something perfectly, because you will have either the computer or the rules of math to interpret the thing that you said. So there's no room there for lack of precision. They force you to precisely define things. Helps in which models help theory testing. So they facilitate designing empirical tests. So for example, in the paper by Sam Stiglitz makes very clear, so defines 2 different types of organizational structures and make very clear predictions. That helped me a lot when I had when I wanted to create an empirical test of that. So the fact that organizational structures were very well defined in terms of 2 numbers, number of individuals and consensus level required, helps a lot to define clear empirical tests. Another one is that models can help you to point out new dimensions to measure. So for example, the paper by March 91 on exploration exploitation introduced those terms, exploration exploitation. And then it provides ideas, by with his model about what these dimensions mean and how you could measure them. It's a way of introducing new ideas. They also provide testable predictions. So the literature I mentioned that starts with Leventhal 97 on adaptation and on NK landscapes produced a number of predictions. And there are several papers now that have tested some of these predictions. One example is this paper by Lennox, Rockhart, and Lewin that look at the effect of complexity on profits in a given industry. And then finally, another general benefit is that models, I think, accelerate the development of science. Why? because models provide clear definitions that enables others to test what you're saying, and then those empirical predictions can be used to refute or not, or to decide to continue building on those theories. So you can cycle more quickly when the foundation of your field is structured in a precise way. That's what Platt calls strong inference. There's this very nice book by Strogatz that talks about how many fields were able to develop with the introduction of calculus. Yeah, calculus essentially what it did is accelerate the development of science because it allowed for these very clear definitions and predictions that enabled theory testing and increased the speed at which science progresses. That's all I have. See you. Bye bye.